Okay, so now we get down to the meat of what's going on in 4.5. So 4.3 was 3 circles. 4.4 was 1 circle. 4.5 is going to involve erasing stuff. Okay, so when I see this bar, so probability of something given, I know I pronounce the bar, given something else, it's a 2-step process. So here I've got this chart down here. Okay, I can put my numbers on here. This is 72. This is 113. This is 185. This is 94 and 91. Okay, that works. All right. So anyway, I've got this chart, and now I've got this problem. The probability of 1 given blue. Step 1. The last thing is step 1, and then the first thing is step 2. So step 1, don't erase. Okay, so this, don't erase blue. Okay, what does that even mean? That means, there's the word blue right there. Don't erase it. There. Okay, I have not erased blue. All right, once I finished with that, so I erased the stuff that didn't involve the word blue. Once I finish with that, now I go back and I read the first part. Figure out, okay, 1. You're only going to use these 3 numbers because those are the only 3 numbers you got. So 42 out of 72. Out of 72. Okay, 0.58333. All right, and this is weird because the denominator, I had the total of all totals out here was like 185. I didn't even use that. The denominator's weird because I erased a bunch of stuff. Okay, and once you get the erasing done, it works out just fine. Now, it doesn't have one on the notes, but if it had had one on there, let's see, this is 52 and this is 61. And if it had said the probability of blue given the 1, that's different than 1 given blue, blue given 1, okay, is don't erase 1. Well, there's 1 right there, and this is lost. Don't erase 1. I just erased horizontally. Last time I erased vertically. I erased the other column. Okay, and the reason for that is it just depends. These 2 things are different from each other. Don't erase 1 is different from don't erase blue. All right, and this was out of 94, so this would be 42 out of 94. Whatever that turns out to be. So the direction that you erase in has everything to do with whatever that word is. All right, now we need to try this other one, other page. Mint, mint, mint bubble, bubble mint, bubble bubble. Ten and 4 and 3 and 7 and 5 and 4 and 2 and 5. All right, so there's these 2 gumball machines, and they spit out 2 pieces of gum. They're probably only supposed to spit out 1. That's why they're defective. But anyway, so I stick my money in. Old gumball machine had cranked a little thing, and I get out a mint 1. And I'm about to walk away, and then I hear cling, and another mint 1 drops down. That's how I know it's defective, because it probably wasn't supposed to do that. Okay, so it could be that I get out a mint 1, and then another mint 1. It could be that I get a mint 1, and then a bubble 1, or a bubble 1, and then a mint 1, a bubble 1, and a bubble 1. And both of the machines are defective, and I keep trying them just to see what happens. I try this one some, I try that one some. I keep track of the things that happened, and that's it. So it's a weird chart because it's got more on it, but, you know. All right, so this is 14, 10, 9, 7, and this total of all totals is 40. Okay, so this is 20, and this is 20. All right, that works. So there's my chart. That's what it is. Probability that I used machine A. Well, you're just knowing. I just ran the experiment 40 times. It says so right here. And half of those times was 20 out of those was I was using machine A. So that's just 20 out of 40. All right, that's just getting used to the notation. Now, the probability that I used machine A given an extra piece of information that I got 2 mint pieces. All right, so instead of reasoning it through, I'm now just going to follow the procedure. What it says to do is don't erase mint, mint. Start with the second bit. Don't erase that. Okay, now I'm going to erase super lightly here. I'm just going to mostly imagine it's gone. That's all not there because I got other problems. I don't want to, like, get in the way of that. But the only column you can actually see, the only thing I didn't erase was this first column right here, mint, mint. So the only numbers I could possibly use are the ones I didn't erase, the 10, the 4, and the 14. Now, go back to this. Probability of A, given that I've only got these 3 numbers. 10 out of 14. Okay, better divide that out. I know it reduces, but I want to figure it out. So I'm just going to go 10 divided by 14.714. Probability of mint bubble or bubble mint given machine A. Okay, so now I would be erasing this way. I don't want to really erase all of this. The only line you can see is that top line, 10, 3, 5, 2, and 20. All right. Then I go over here to part 1. Okay, I've done the A. Come back and do this. Mint bubble or bubble mint. Okay, let's see. So I don't forget about all these numbers. They're erased. But this definitely has something to do with the problem. And so does this, because these are mint bubble, bubble mint. Forget these numbers down here. You can't even see them. Okay, but those two. Now that's not 3 circles, but this is a really weird chart because it's like a 4x2 instead of the usual 2x2. Okay, but the or, I know how to do or. You circle anything that applies to that. So those two are my numerator. And my denominator, remember you can't see any of this stuff right here. My denominator is that 20. Denominators change in these problems. Okay, so 8 divided by 20. Point 4. All right. Now, probability of bubble bubble given machine B. All right. So, don't erase B. All right, so erase this top line before I had left line A and erase line B. But now I'm supposed to leave line B, erase that top line right there. You can't see that anymore. This is my last problem. I might as well start erasing. Okay, and you can't see the totals either. The only thing not to erase is B. So there's B not being erased. All right, got that done. Now let's get back to this. Bubble, bubble. That's this one right here. 5 out of 20. So that's like 1/4, so that's 0.25.